Okay, so continuing from my last video on antiderivatives, I'm just going to be doing some more examples and wrapping up this whole topic. So another example I have here is I have f double prime of x is equal to 8x cubed plus 5, and I'm also given these additional tasks to accomplish. I'm given f prime 1 equals 8, f of 1 equals 0. So just by seeing this, I know I'm going to have to find a c value and everything like that, like we did last time. And I'm even going to have to find a d value, which we'll go into as well. So the first thing I want to do is I just want to find out what my f function is and my f prime function is and my f function is. So let's just do that really quickly. So using the power rule, I have 8x cubed, and I'm going to add a 1 to this 3. So 8x to the fourth. So that becomes 8x to the fourth divided by 4. And you can see that's just going to be 2x to the fourth. So I'm just going to write that down here. So 2x to the fourth. And then remember what I said about constants is you'll just tack on an x value after it, or whatever variable you're dealing with, and then plus c. And if it seems like I'm streamlining this, by the way, just be sure you watch my first video on this topic, where I definitely slow down on the power rule for antiderivatives, and I explain what I'm doing with constants and everything like that. This is just the second part of the series. Okay, so now I have to take the antiderivative one more time. So add 1 to the 4 and divide by that. So 4 plus 1 is 5, so I get 2/5 x to the 5th, where I just divided that 2x to the 4th by 5. So that's 2x to the 5th over 5. But remember what I said earlier is I like to bring this portion out front. So that's just 2/5 x to the 5th. Okay, and then we'll do it one more time. So I'm going to get plus 5 over 2x squared plus, remember what I said about constants, you just tack on an x, but whenever you take an antiderivative, you need some constant. So I'm just going to call that constant d. And I can't use c because I already used c right here. Okay, well, if this part wasn't here, if that wasn't there, then this would be my final answer. But since that is there, I need to be able to find out what c is and what d is. So let's start by just finding out what c is. So I'm going to use my first derivative. I'm going to use my f prime function in order to find that. So it's being set equal to 8, and we're plugging in a 1. So we're plugging in 1 for x, and this is all being set equal to 8. So okay, so I'm going to say 8 is equal to 2 times 1 to the 4th plus 5 times 1 plus c. So I'm going to get 8 equals 2 plus 5 plus c. 8 equals 7 plus c, hence c is equal to 1. C is equal to 1. Okay, now I want to find my d value, so I'm going to use this function because this function is the only one that deals with d. So I'm plugging in 1 and I'm setting it equal to 0. So just make sure, yeah, okay, setting it equal to 0. So 0 is equal to 2/5 times 1 to the 5th plus 5 halves 1 squared. 5 halves 1 squared plus, remember c was just 1, so 1 times 1 plus d. And this is going to simplify to just negative 39 over 10. So d is equal to negative 39 over 10. And I already had this portion written down. I didn't really want to waste time computing all of this. I want to keep this video short and cram in as many examples as I possibly can. So okay, now let's just finish this. So all I have to do is I just have to rewrite my f function right here with my c and my d values. That's all I have to do. So let's just do that and wrap up this problem. Okay, let me just underline this d answer, and okay. So I have f of x is equal to, and what did we say? It was 2/5 x to the 5th, 2/5 x to the 5th, plus 5 halves x squared, plus 5 halves x squared. And then c was just 1, so that's just plus 1x. And then that d is negative 39 over 10. So I'll just say minus 39 over 10. And that's my answer. That is my f function with c and d solved for. 2/5 x to the 5th plus 5/2 x squared plus 1x minus 39 tenths. And that's it. So quick recap is that I was given an f double prime and it wanted me to find f. Well, to do that, I took the antiderivative twice and I saw that I get a c value and a d value. And I have to solve for these is because it gave me this additional prerequisite. I was given f prime 1 equals 8, f of 1 equals 0. When it gives you these additional things to do, that means you have to find out what c is, or find out what d is, or find out what both are. So in order to do that, I just set, I set these equal to their respective functions. So f prime of 1 equaled 8. So I set it equal to 8 and I plugged in a 1. F of 1 equals 0, so I set this equal to 0 and I plugged in a 1. And I solved what c and d were. And then once you have those c and d values, you rewrite your f function, but you use your c and d values. So c was 1 and d was negative 39 tenths. And that's it. So pretty easy once you get the hang of it. It's just a little tricky at first. So now let's do a couple more examples that deal with other cases for antiderivatives. Okay, so let's say I was given f of x is equal to 1/5 minus 2 over x. And so let's pause and do a really quick example to the right-hand side. Let's say I had 1 over x, and I wanted you to find the antiderivative of that. Well, you'd say, okay, that's easy. I'm just going to bring this up, make it an x to the negative 1, and I'm going to use the power rule on it. Well, okay, that's fine. So I get x to the negative 1 plus 1, which is just 0, because you add 1 to the exponent, and then you divide by that exponent. But you see here that I'm dividing by 0, which cannot be done. So the power rule doesn't work here, which is very, very peculiar. So what can I do? So if you're given, x to the negative first, or 1 over x, this ends up becoming ln of the absolute value of x plus c, if I wanted to take the integral of that, or the antiderivative. Again, they mean the same thing. So let's just keep that in mind. So this will become ln of the absolute value of x plus c. So if I want to find the antiderivative of this, I'd say capital F equals, remember what I said about constants is that they stay there, you just tack on an x after it. So 1/5 x minus, well here, this is the same thing as 2 times 1 over x. So you could say this is equal to minus 2 ln absolute value of x plus c. And that's your answer right there. Again, any constant on top stays along. So this could have been like a 99. Then I would have had minus 99 ln of x plus c. But since 2, it stays along for the ride. And that ln of absolute value of x is just the integral or antiderivative of 1 over x. And that's my answer. So 1/5 x minus 2 ln absolute value of x plus c. So that's just another one I really wanted you to be familiar with. So let's do another one. Let's say I had f of x equals 2 to the power of x plus 4 hyperbolic sine x. And I wanted the antiderivative of that. Well, this is definitely tricky. So if I differentiated this 2 to the x, you get 2 to the x ln 2. Well, for antiderivatives or integrals, it's the same process, except it'd be 2 to the x over ln of 2. So it's really just one step further. It's 2 to the x over ln of 2. So I'm going to write that, and that's just another formula to remember. So 2 to the x, or any power to x. So n to the x equals n to the x over ln of n, just as a generic way of writing that. So this becomes 2 to the x over ln of 2, And then think, the derivative of what is hyperbolic sine? And the answer is just hyperbolic cosine. So 4 hyperbolic cosine x plus c. You always tack on the plus c value. So my answer is 2 to the x over ln of 2 plus 4 hyperbolic cosine x plus c. And that's my answer. Okay, so we're making steady progress. Let's do another example. I'm going to clear the board really quick. And again, those with the ln of absolute value of x and then the power, 2 to the x, those are just some more rules to remember for antiderivatives. So let's do a trickier one. Let's say I had f of x is equal to 1 plus x squared over rad x. And I wanted the antiderivative of that. Well, what can I do here? So remember that for antiderivatives or integrals, there are no magical rules that you can use to handle division or multiplication. There is no product rule. There is no quotient rule. There's a bunch of techniques you'll have to use later on in order to do this. But the first thing you always do is you see if you can do an algebraic manipulation to rewrite this, because antiderivatives can move through addition and subtraction. If I have separate things, like a let's say a plus c plus b, I can take the integral of each one of these. But if I have multiplication and division, there's not much I can really do. So I'm going to make an algebraic manipulation to see if I can make this just a bunch of addition. So what I'm going to do is I'm going to break this up, and that's a really common technique to do. So 1 over rad x plus x over rad x plus 2 over rad x. And sorry, this is still f. This isn't the antiderivative yet. I'm just manipulating this. Okay, so now I'm just going to simplify this even more. So x to the negative 1/2 plus x to the first over, x to the 1/2, x to the 1/2 plus 2 over x to the 1/2. And I'm going to get f of x is equal to x to the negative 1/2, x to the negative 1/2 plus x to the 1/2. So I'm just using properties of exponents. I'm subtracting 1/2 from 1. 1 minus 1/2 is just 1/2. And here it was, 0 minus 1/2, so it's negative 1/2. And then plus 2x to the negative 1/2. So now let's take this antiderivative. Well, I'm going to use the power rule here. I'm going to use the power rule. So uppercase f is equal to, well, I'm going to divide by, I'm going to add 1 to this negative 1/2. Negative 1/2 plus 1 is 1/2. And divide by 1/2. Okay, and then the same thing here. X to the 1/2 plus 1, that's x to the 3/2, and you divide by the 3/2. And one more time, x to the negative 1/2. That's just what that is that just hold on. Oh, I'm sorry. This was supposed to be an x squared right here. My bad. So an x squared. Okay, that makes more sense. So this one, this bit right here, this would just become, so 2 minus 1/2, that gives me x to the 3/2. That makes much more sense. Okay. Okay, so this 3/2, so if we add 1 to it, we would get x to the 5/2, and then we divide by that. Okay, so now let's just finish this up, and a plus c value. Okay, well, if I want to simplify this, remember that dividing by a fraction is the same thing as multiplying by the reciprocal, because this is x to the 1/2 over 1 over 2. But I could just rewrite this as 2x to the 1/2. 2x to the 1/2. And then multiply by the reciprocal for here, so 2/3 x to the 3/2 plus 2/5 x to the 5/2 plus c. So I get 2x to the 1/2 plus 2/3 x to the 3/2 plus 2/5 x to the 5/2 plus c. So long answer, but pretty doable. Again, don't make the same mistake I did. You know, I wrote down the problem wrong. It's just x squared was supposed to be, or that 2 was supposed to be an x squared, but I fixed it. So that's my answer for this one. And let's just do one more example. Let's just do one more example. I'm going to clear the board really quickly. And we'll do this one. So let's say I'm given h of x is equal to 2 sine x minus secant squared x. And I want to find the antiderivative. So I'm going to find capital H or big H. Well, I got to think to myself, the derivative of what is sine? The derivative of what is sine? Well, is it cosine? Well, remember if I differentiate cosine, I get negative sine. But this isn't a negative sign, this is a positive sign. So what I'm going to have to do is I'm going to differentiate a negative cosine. Then I would get a positive sign. So hence my answer is this becomes a negative cosine. So negative 2 cosine x. Remember the constant just stays along. Minus, and then the derivative of what is secant squared? The derivative of what function is secant squared? And the answer is just tangent. And then you always tack on the plus c. So my answer is negative 2 cosine x minus tan x plus c. And that's my answer. So that covers most of the rules you're going to see. Definitely not too bad. Just practice with these integrals or antiderivatives. I obviously wasn't able to cover every single one you're ever going to see in your entire life, but hopefully this helps you get a strong understanding of what you're supposed to do. And again, if you have any more questions on these, feel free to send me a message. I'm always more than happy to make any videos you need. And as always, thanks for watching.